Hello student, last time we did the central points related to a triangle, and in this one, in this topic, we did the centroid of a triangle and incenter of a triangle. Now this time we will move ahead with the next point, that is called excenter. Excenter of a triangle. Student, first of all, what is the excenter? In the incenter, what we did in the last time, in the case of the incenter, if the bisector of angles intersect each other, that is called the internal angle, intersect each other, then that point of intersection will be the incenter. But in the case of the excenter, so student, you can see this is the triangle ABC, and when you extend the sides of the triangle, then you will get three circles which touches all the sides of the triangle. The center of all these circles are called excenter, and the circles are called X circle. First X circle, second X circle, this is the third X circle. The center of, suppose it is first, the center of the circle is, this is second, and this is the third center. I am taking here as O1, I am taking here as I1, I2 and I3. You have to find out the coordinate of these three excenter when the vertex of triangle is given. Suppose this is first vertex A, whose coordinate is x1 comma y1. This is the B, second vertex, which is x2 comma y2, and this is the third vertex x3 comma y3. Now in this case, what will be the coordinate of first excenter I1, I2 and I3? So for the I1, what we'll do, in the incenter we did the coordinate is ax1 plus bx2 plus cx3 upon a plus b plus c, comma, then I1 is, that is the first excenter, is. So we will just make some change in the incenter. What we did in the incenter, it was ax1 plus bx2 plus cx3 divided by a plus b plus c, comma, ay1 plus by2 plus cy3 divided by a plus b plus c. Now this was your incenter, but now we have to find out the excenter. So for the excenter, what we did, this is the I1 which is just opposite to the vertex A, which is just opposite to the vertex A. So the vertex A, that is x1 and y1, we will make it as negative, 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 negative. It means finally the I1 becomes minus ax1 plus bx2 plus cx3 upon minus a plus b plus c, comma, minus ay1 plus by2 plus cy3 upon minus a plus b plus c. Similarly, I2 is ax1 minus bx2 plus cx3 divided by a minus b plus c, comma, ay1 minus by2 plus cy3 divided by a minus b plus c. And I3 is ax1 plus bx2 minus cx3 upon a plus b minus c, comma, ay1 plus by2 minus cy3 divided by a plus b minus c. So this is the coordinate of 3x center which lies outside the triangle like this figure. These are I1, I2 and I3. Now student, I am taking the next topic, which is the circumcenter. Circumcenter is a point by taking as center and radius equal to the distance between the point and the vertex of the triangle. If you draw a circle, then that point is called the circumcenter. That is, you can say in other way, you can say that there is a triangle. Now through these three vertices of the triangle, if you draw a circle, then center of that circle is called circumcircle. Now the circumcenter. Circumcenter is a point which is a center of the circle passing through the vertices of a triangle. I'm just making the figure, and by using that figure you can understand what is the definition of the circumcenter. You can see here, this is the triangle, this is the circle passing through the three vertices of the triangle. Now center of this triangle is called the circumcenter. So if you consider, this is the point A, this is the vertex A whose coordinate is x1 comma y1. This is the point B whose coordinate is x2 comma y2, and this is the point C whose coordinate is x3 comma y3. Now you have to find out the circumcenter. Student, you did in class 9th or 10th that from the center, the perpendicular drawn to a chord always bisect the chord. So in other way, you can define the circumcenter as point of intersection of perpendicular bisector of side. So it is when you draw the perpendicular bisector. So this point is circumcenter. The perpendicular bisector meets at a point. The perpendicular bisectors of a side meets at a point O. So O is the circumcenter of the triangle, and from this O, the distance of each three vertices are equal, are same. That is OA equal to OB equal to OC. Now you have to find out the coordinate of O. So the coordinate of O, what we'll do to get the coordinate? We will suppose this coordinate of O as x comma y. Now from O to A, we will find the distance by using distance formula. We'll find from O to B the distance by using distance formula, and from O to C we'll find the distance by using distance formula, and we will equate all of these three distance. That is OA equal to OB equal to OC. By using this equation, we will find out the value of x comma y. Or we can write the coordinate of O, that is the circumcenter, as x1 into sine 2a plus x2 into sine 2b plus x3 into sine 2c divided by sine 2a plus sine 2b plus sine 2c, comma y1 into sine 2a plus y2 into sine 2b plus y3 into sine 2c divided by sine 2a plus sine 2b plus sine 2c. So this is the circumcenter. Always remember, in class 10th you did that the midpoint of a right, in class 9th or 10th you did that the midpoint of the hypotenuse of a right angle triangle is equidistant from all the three vertices. It means always for a right angle triangle, the midpoint of the hypotenuse becomes the circumcenter of the triangle. Now student, it is orthocenter. Orthocenter is, so this is the point of intersection of all the three altitude of a triangle. So student, you can see here, this is triangle ABC, AD, BE and CF are three altitudes drawn from the opposite vertices to the opposite side. Now, these three altitude intersecting at a point, that is the common point, and this common point is called the orthocenter, and this is, in general, it is denoted by H. Now you have to find out the coordinate of this H. If the coordinates of A as x1, y1, B as x2, y2 and C as x3, y3 are given. So student, one of the way is find the equation of BC. So one of the method is find the slope of BC. From there you can find out the slope of AD. So one of the method is find the slope of BC. Then from there, because AD is perpendicular to BC, so you can find out the slope of AD as m1 into m2 equal to -1. You have the slope of AD, you have the point A x1 y1. Similarly, we will find the slope of AC. From there, we'll find the slope of BE. Slope of B, you have the point x2 y2 on BE you have, so you can find out the equation of BE. Now to get the coordinate of H, we will solve the equation of BE and equation of AD. By solving those two, we'll get the coordinate of H. And the second way is the coordinate of H is, you can remember the direct formula, it is x1 tan A plus x2 tan B plus x3 tan C divided by tan A plus tan B plus tan C, comma y1 tan A plus y2 tan B plus y3 tan C divided by tan A plus tan B plus tan C. So this is the coordinate of orthocenter. Now student, I am writing here the properties related to these four things, that is centroid, incenter, orthocenter and circumcenter. So these are the properties.